Hello friends, my name is Jomin George Attayil. Today we are going to see a topic which is explanation based learning, which is otherwise called EBL. First, we will see the definition of explanation based learning. Explanation based learning, otherwise known as EBL, is a method for using available domain knowledge to improve supervised learning. That is, the EBL comes under supervised learning and it will use the domain knowledge, that is, a knowledge base which contains all the domain based information which is used to improve the supervised learning. Then, why we are using explanation based learning? It can be in speed of learning, confidence of learning, accuracy of the learned concept, or a combination of these. What are they? Can be in speed of learning, confidence of learning, accuracy of the learned concept, or a combination of these. EBL computers use the domain theory to inherit the properties of examples. Here, EBL computers, otherwise, these are the agents. Here, the examples are nothing but a part of domain, and domain means the collection of all examples. By using examples only, it will inherit or infer the domain specific knowledge. So this is called as explanation based knowledge. So explanation based learning is a method for extracting general rules from individual observations. What is that? What is extracting general rules? Let's consider an example. Mango is sweet, banana is sweet, and apple is also sweet. So these are the individual examples. From this, what general rule? We extracting all fruits are sweet. So all fruits are sweet is the general rule. So likewise, by using EBL, we will extract the general rules by observing all the individual examples. Here the examples are called as member of concepts. When comes to the next point, a part of the domain is called an example, is a member of concept. So in the domain which contains a collection of examples, which is otherwise called as member of concepts. When come to the next point, learn the essential properties of the concept. So for all the examples are concepts, we should learn the essential properties. In our example, that is fruits example, the essential property is whether the fruit is sweet or not. Okay. Next one is trade-off. Why we are using trade-off here? The trade-off, the need to collect many examples for the ability to explain single examples, a domain theory. That is, we are collecting many examples. By observing all the examples, then we will give the definition of particular examples. So this is called as explanation based learning. There are four kinds of input in explanation based learning. The first one is goal concept, the next one is training example, and the third one is operational criterion, and the last one is domain theory. The first one is goal concept. We know what is a goal, isn't it? A goal concept is a high level description of what the program is supposed to learn. The next one is training example. Training example is what the learning sees in the world. That is called training example. So collection of examples will be there and we are going to learn from the examples. Next one is operational criterion, which is otherwise called as facts, a description of which concepts are usable. That is called operational criterion. We are going to observe only the usable concepts. And next one, very important one, is the domain theory, a set of rules that describe relationship between objects and actions in a domain. That is domain theory. So these four are important concepts that will accepted by the explanation based learning. So these four are otherwise called as inputs. What are they? First one is goal concept, training example, operational criterion, domain theory. So by these use the problem solver. Which is the problem solver here? EBL is the problem solver here, which is to justify using the rules. Rules are nothing but the domain theory, the goal in terms of facts. So by using the usable concepts, we are going to achieve the goals by using the set of rules, that is the domain theory. This diagram explains the general approach to explanation-based learning. Here, set of facts are given and these facts are called as examples. And by using these examples, the learning process will be started by applying all the rules, and we rewrite the rules and we inferring the new rules. And finally, we reach the goal. Once we reach the goal, that is no need of learning again all. The facts will be directly connected to the goal. So this goal is called as generalized goal. Here, explanation-based learning computes a generalization of the training example to describe the goal concept. It also satisfies the operational criterion, that is the given set of rules. And the explanation-based learning has two steps. First one is explanation and second one is generalization. Explanation means the domain theory is used to remove all unimportant aspects of the training example with respect to the goal concept. And the generalization means the explanation is generalized as far as possible while describing the goal concept. So we need to give only the generalized goal that should satisfy the all rules and that should be suitable for all the examples also. So this is called as explanation based learning. And now let us see one example for EBL. EBL is a method for extracting general rules from individual observations. As an example, consider the problem of differentiating and simplifying algebraic expressions. And we will take one simple expression, that is x square with respect to x. And what is the differentiation of x square? That is, the result is 2x. In a logical reasoning system, the goal must be expressed as, here we are going to express this particular thing. Ask. Ask is a method. Ask of derivative of x square x, which is equal to d. D is nothing but differentiation with respect to kb. Kb is knowledge base. And the solution of d is 2x, because we already know what is the differentiative value of x square. So x square is 2x. In this example, we are going to use the standard rules of differentiation, which gives the expression in the form of 1 into 2 into x to the power of 2 minus 1. And this is the simplified form of the particular expression, that is 2x. X to the power of 2 minus 1 is x raised to 1, that is x. And 1 into 2 into x is simply 2 into x. So the result is 2x. Then explanation based learning memorization. Once the general rule is identified, then immediately that should be memorized, that is stored in a cache memory. Whenever it finds an example, immediately it will apply the same rule that is taken from the cache memory on the example. Now let us see the importance of memorization in explanation based learning. In our differentiation example, we receive the example x square with respect to x. Here x is the random variable. We need to solve this equation by applying the differentiation rule. Then we get the result is 2x. Now we'll get another example of z square with respect to z. Here our random variable is z. we need to solve this z square by applying the differentiation equation. So we need to extract the general rule for any arithmetic unknown u. U is the random variable. The derivative of u square with respect to u is 2u. So this is the general rule of differentiation that we need to memorize. In logical terms, this is expressed by the rule arithmetic unknown of u gives derivative of u square u equal to 2u. So this is the generalized rule of differentiation. Next one is extracting general rules from examples. Here first we should construct the explanation of the observation. Here observations are nothing but examples or samples. We are going to observe those samples and construct the explanation by using the prior knowledge. So prior knowledge means already a set of rules stored in knowledge base. By using those rules, we are going to observe the samples and we should construct the explanation, and this is otherwise called as the definition of the classes. Here classes are nothing but examples or samples. To establish a definition of the class, that is examples or samples, for which the same explanation structure can be used. That is, the rule is generalized rule that we constructed by using the definition which is suitable for all classes, and the explanation is nothing but the logical proof. It is otherwise called as reasoning or problem solving process. That is, we need to construct well defined explanation used for problem solving process. And this is the basic EBL process, which is working as follows. First, we should construct the proof tree by applying the background knowledge, and simultaneously we have construct a generalized proof tree by using the same inference steps as per the original proof. Then construct a new rule whose left hand side consists of the leaves of proof tree and whose right hand side is the variabilized goal, and then drop any conditions that are true irrespective of the values of the variables in the goal. These are the basic EBL process. So this video is all about the EBL, that is explanation based learning, and its 4 inputs. The 4 inputs are goal concept, training example, operational criterion, and the final one, the domain theory. And also we explained the process of extracting general rules from example in explanation based learning. I hope all of you enjoyed the video. Thank you.